All right, welcome. Today we're looking at introducing quadratic functions. So we're going to revise a little bit of what we know from last year, but our key goals for today for the quadratic functions is that we can identify and sketch the key features of a quadratic model, and that we can interpret information from quadratic models. So this means that we can identify key characteristics either from the algebra or from the shape of the graph. So to start off with, we have this pair discussion. We're just going to review how to expand brackets a little bit. Now we're going to use FOIL for this. So here on this first one, we want to FOIL this one out. What are we going to get? Can anyone help me with this one? Alec? X squared plus 5x plus 6. All right. How about the second one? This one gets a little trickier. So I'm going to do this one the long way. We're going to start with our FOIL first, outer, inner, and last. We'll do it in that order. So what do we get for this one?
6x squared minus x minus 2.
We're going to get 6x squared, and then we're going to get, what are we going to get next? We're going to get minus 4x plus 3x. I'm going the long way. And what's our constant? Minus 2. And then, like you say, we minus 2. And how about this last one? What do we get for this last one? We're going to get 2x squared, Barn. And then what? I'm going to do, we did that one. I'm going to do this one next. What's that? No, 2x squared. We can simplify this one a little bit to 2x squared plus 2k minus 1 x minus k, if we wish. This type of factorization isn't necessarily required on this course. At best, you'll be asked to expand the bracket and then maybe differentiate it next year, and that would be enough. All right, so let's have a look at the key information about quadratic functions. So quadratic functions are polynomial functions with the highest order is 2. So we can see in this example here, our general form for the quadratic function, and we notice ax squared plus bx plus c. On this particular one, the highest degree of this function is 2 because we have a 2 here. There's the shape of the curve. The curve goes up like this and then down again, or down and then up. We call this a parabola, which is the type of function. And hopefully we've seen these before. So just looking at this function, why in the general form is a equal to 0 not allowed? If we look there, it says a can't be 0. Why not?
Because a determines how narrow or wide the parabola is, and if it's 0, it's
Yeah. So what she's saying basically here is if a is equal to 0, this term's going to disappear, and you would be left with f of x equals bx plus c, which is a straight line equation. You'd end up with a linear function. It's not going to be quadratic anymore. Okay, how do linear graphs and quadratic graphs differ, and how are they the same? A linear graph is a straight line. A quadratic graph is a curve. A quadratic graph rises and then falls, or it falls and then rises. It goes in both directions, whereas the linear graph either just rises or just falls. Right, so one of the most important parts about a quadratic graph, and the reason we find them useful, is they have a maximum point or they have a minimum point. So they have a maximum point or a minimum point. We call this the vertex. We need to know the word vertex. So what would be the domain of this function here? What would be the domain of this function that's drawn? all real numbers. So our domain of the graph is all real numbers. So we can say that X is a member of the set of real numbers. This would be the domain. So any number can be X.
Can you say the domain is negative infinity to positive?
Yeah, I think I wouldn't penalize you if you were to say this, that the domain is in between negative infinity and positive infinity. And again, you can use interval notation for this as well on this course if you wish. The IB tends to prefer, and the mark schemes will use inequalities like this, as opposed to the interval notation like this one. But they're all acceptable. And the easiest way is saying X is any real number. You can even write it with words. Domain, any real number. What about the range? Can we see the coordinates of this vertex? That would be at 10, 5, would we say? Yeah. So what would the range be? Yeah. So the easiest way of doing that one would be say that the y values are less than or equal to 5. And this would be our range. You can do it from negative infinity up to and including 5, like this, if you wish. All right. Okay, here's a question for you to have a go at. Plot this on your calculator and then do a sketch. I'll take 4 minutes for this one and I'll come round and look at your work on your page. So let's have a look now. We need to sketch the graph first on our calculator. So on your calculator, press Control, Add Page, and we're going to add a graph. We are going to type this in minus 0.5x squared. Oops, I've got an extra 0 in the wrong place. Minus 0.05 x squared plus 7.5x minus 18. Now, when we first look at the graph, we don't see all the information that we want to see. If we zoom out on this one, typically zooming out doesn't help us that much in that we go in the wrong direction a little bit. So I'm just going to start with a zoom out. I'm going to press Menu, Graph, Zoom out. And if I click here in the center of the graph, it zooms out a little bit. I'm not seeing all the information that I want. And if I keep zooming out, it just gets narrower and narrower. So if you get an idea about where you want to be, then I'm just going to adjust this. So I don't need much in the negative direction, so I'm going to go minus 5 there. I don't need as much in the positive direction of x, so I'm going to make this 20. That looks good. I can trim off a little bit here, bring this down to 15, and I can see so you want to make sure you can see the vertex here, the axes intercepts on the x-axis here, and on the y-axis there. Now let's find that information. So if you remember, we press Trace Graph first, type in 0, press Enter twice, then press Escape, and that disappears. Next, we want to use the Analyze Graph, find the zeros. I'm going to click either side there, repeat that one for the other one. Analyze Graph, find the zeros, grab that one, and lastly, Analyze Graph, find the maximum. And there's a maximum up there somewhere. There we go. So now we've got all the information. We want to sketch it. So when it comes to sketching it on our sketch graph, start with a ruler and draw your axes, but don't draw a scale. Remember, for a sketch graph, we don't want a scale because that just makes it harder for us to draw it. Oh, my straight line didn't work. There we go. So just draw your axes like this. Label our axes, X and Y. Next, we want to just sketch the graph as we see it and make sure you get the shape right. This is why we avoid having the scale, as it will help us just to get the correct shape. So we want our shape to look something like this. Make sure it looks like a parabola. Doesn't matter if it's a bit lower like this or a little bit higher, there's no scale on it, so I'm still correct. So I'm going to place it like this so that I've got space to get all my labels in that I want. This point here is going to be at 0, 18. This one here is going to be at 3, 0. Oh, yes, thank you. Negative 18. Sorry, let me make my pen a bit thinner and draw these a bit clearer. So this one is at 0, negative 18. This one is at 3, 0. This one is at 12, 0. And our vertex is at 7.5, 10.1. There we go. We've got all the key information of the graph in the sketch. This is how our sketch should look. And this is how long it should take. It should take us a minute or two at best. Is an important skill to be able to find it on the calculator, to adjust the axes. So, all right. Okay, let's move on to our next question. I'd like you to have another go now. See if we can do it quickly. Pick one of these questions. Pick any one that you wish and sketch this one. We'll take it 2 minutes. 2 minutes for this one. Results of our... Where are we? We are here. All right. Let's have a look at the results of our investigation. So here in this first one, so if we're looking here at this one, what are the values of A? We've got 1, 4, and 3. Which is better pencil? That's 1, 3. What's the y-intercept? 0, 3?
Yeah.
And is it a minimum or a maximum?
Minimum.
This is a minimum. Let's have a look at the next one. What's the values of A? Minus 1. 1. The y-intercept?
0,2.
Min or max? Max. And then let's look at the D. 2 minus 8 minus 10. 0 minus 10. Minimum. Somebody else help me with this one here. There we go.
Minus 2.
Sorry, Yasin. Minus 2. 3. 9.
0,3.
0, 9.
Oh, sorry.
Min or max?
I'm reading the wrong one.
You're reading the wrong one. All right, you want to redeem yourself with the last one? Make sure you read the correct things.
Okay. 4. 4 minus 8, 3, and then
4 minus 8, 3.
0, 4. Wait.
0,
0,
3. How about Yasin shuts up and Austin takes over? Minimum. All right. So in this investigation, we want to figure out, we had to draw each one, and that was good practice sketching things on our graphing calculators for those of us that brought their calculators today. How can we tell whether it's what the y-intercept is by looking at the graph? Looking at the function. Malak.
It's the last number,
So-
without the x.
It's the value of C
Yeah.
will tell us the y-intercept. Don't say the last number necessarily if it's not written in standard form. If it's in standard form of ax squared plus bx plus c, the last number. But if they write it as c, let's say they said the first one was minus 5 plus 4x plus x squared. They've not written in standard form and you'd be confused. So it's the value of c. How do we tell whether it has a minimum or a maximum? So these ones have minimums. These ones have maximum. How can we tell? Barn. Look here. The two maximums have a negative value for A. And the minimums have a positive value for A. So let me do a little summary up here for us on this one, because this is a key point. We've got two types of graph that we can have in terms of the A value. Now it's either going to look something like this, or it could look something like this. This one has a minimum. This one is a maximum. The value of A for a minimum is going to be positive, and the value of A for a maximum is going to be negative. So this is the key information for this concept. All right. So let's have a look at our last concept, and it's the axis of symmetry. So we've got a new formula here for us today for the axis of symmetry. We can take 2 points such as the x-intercepts and find their average value, and this will give us the axis of symmetry. This formula is not on the formula booklet. This formula is not on the formula booklet. You need to learn this one yourself. It is a useful formula.
Sorry.
Yes?
Wouldn't you just be able to look at the graph and determine the x value of the vertex? Or vertex.
If the graph is drawn.
Oh.
If you have the graph. But sometimes, for some problem situations, you want to know this concept. It doesn't even have to be the axes intercepts. It can be any 2 points which have which share the same y value. So for instance, if this is your x1 and this is your x2 here, the formula will still work as long as they share the same y value. This was going to help you with some problem solving questions. All right, so the axis, why is the axis of symmetry important? What does it tell us? The vertex. The axis of symmetry is all about finding the vertex. So if the axis of symmetry is x equals a, that means that the vertex is going to have the coordinates a, comma, f of a, where f is the function. The axis of symmetry tells us the x coordinate of the vertex. So let's have a quick go at this question over here. What would the axis of symmetry for the curve passing through these points be? Let's have a look. So we need the formula. X is equal to, and we just add them together and divide by 2. What's minus 3 plus 4? Sorry, minus 4 plus 3.
Minus 7.
No.
Minus 2. Oh, 1 minus 1.
Minus 1. So the axis of symmetry is x equals minus a half, or minus 0.5. Work out for yourself what the axis of symmetry will be for question B. What's the axis of symmetry going to be here? No, you can leave it as a fraction. All right, let me take Farah. So we need the formula. X equals, what goes in the numerator?
1 plus 5.
1 plus 5, all over what?
2.
2. We're finding the average of those two numbers. So we get 6 over 2, which equals what? 3. Our axis of symmetry always has to be an equation. X equals 3 is the correct answer. Yeah. Okay. Here we have a bit of a problem-solving question. What are we doing? A quadratic function has the y-intercept 0.0, an x-intercept of minus 3, 0, and an axis of symmetry of x equals 1. What's its equation going to be? How can we do this? discuss with the people next to you for a minute. How can we solve this? What could we do here? Let's have a look. Okay, so what we need to do for this one, it's like there's a lot of information here and you need to try and figure out what to do. Your best, Harmon, try and focus, stop playing games. The best strategy when it comes to problem solving is to take the question and make it into a diagram. Try and make a diagram to help you as a problem solving strategy. So the first thing we want to do for this one is make a sketch. So I'm going to draw some axes like this. And I've got some information. Let's put the information into the diagram. So we know, first, I'm going to start off with the axis of symmetry over here. We've got the axis of symmetry there. So that means we've got a line like this. Sorry, I'm not quite sure why the screen mirroring isn't working. Let me see if I can plug it in, if it cheers it up a little bit. No? All right, so we've got our axis of symmetry at x equals 1. Sorry. All right, so we've sketched the axis of symmetry. We've got another piece of information over here, the axes intersect. Let's try and see whereabouts that one's going to be on the graph. So we're down here somewhere like this. It's going to go through minus 3, 0.
So that's the line of sight.
Oh, sorry. It's not going to be down there. The axis intercept is going to be over there, isn't it? Minus 3, 0. What else have we got? We've got this one. That's the y-intercept. That one's going to be up there. That one's going to be 0, 4. So at this point, does this graph have a maximum or a minimum?
No.
How can we tell?
Because
We know the vertex has to be there on that line, and we have to pass through those 2 points. So that gives us those 2 points. We go through there, and we got our vertex up here. Can we find this point here?
Yeah.
How can we find this point here?
You flip it over from -3 to 3.
We flip it over from -3 to 3. So what distance is that? How far from the axis of symmetry are we traveling?
6.
This is at 1, and this is at -3. This is -4. So we need to go in that direction by 4. So what is the coordinate of that other axis of symmetry? This is 5, 0. Now, what we need to do to solve this is we need to find what the values of A, B, and C are. From this information, can you tell what any of those values are? Can we tell what C is?
Yeah.
What's C? So we can say that C is equal to 4. So we have f of x is equal to ax squared plus bx plus 4. We're getting a bit closer now. So you have it. What we need to do is we need to form some equations. And there's a few different equations we can form. We can form an equation using, firstly, I'm going to use this fact here, -3, 0. That's an x and a y value. I can put it into the equation. So the y value is 0 when x equals minus 3. So what's minus 3 squared?
9.
So we get 9a minus 3b plus 4. I've inserted the x and y values. Let me do that a bit slower. So if I put the y value as 0 and the x value as negative 3, I get this equation, and then I expand it and I get that one. Can we form an equation in the same vein using this coordinate? What would it be? Leonardo, pay attention. What would the equation be if I put 5, 0 in? What's the y value? 0. What's 5 squared?
25.
So now we have an equation system. So what we need to do at this point is we need to use the graphing calculator to solve the equation system. So let me pop that up here. So we can type this into the graphing calculator using menu, algebra, solve a system of linear equations. We can change from x and y to a and b. And then we can type the equations in as we see them. So we got 0 equals 9a minus 3b plus 4. And 0 equals 25a plus 5b plus 4. This gives us our answers. Just checking through that we've got the right ones. We've got 9a, yeah, minus 3b plus 4, 25a, 5, yep. So this gives us f of x is equal to minus 4 over 15 x squared plus 8 over 15x plus 4. And that's our function. So in this case, I've used two of the values to form up two equations and then an equation system to get to our answer.
Wait, so how did you use the equation system?
On the graphing calculator, with the technique that we saw in the last unit for solving a system of equations, and you can see, and you can watch it on the video. Okay, our last one. Have a go at this one for yourself. Have a go at this one for yourself. I'll give you 4 minutes. This is a very typical exam style question that we're doing here. Very typical exam style question. So we've got the height of the ball is given by the model. So the first thing that we want to do is we want to take this model and graph it. So one of the key skills we're working on today is to be able to graph a function and see all the key information. And that's the answers to most of these questions. So if I start by adding a graph to my calculator and I type this one in, 1.5 plus 23x, I do a transposition of x, t for x, 4.9x squared. Now we can't see all of the graph, but if we adjust our axes, I'm going to adjust the y-axis to go up to 20. Nope, don't see it. Let me try again. Let me try 40. There. I can make this one a bit smaller. Make that one 5. And I don't need negative values because, well, time can't be negative. So I'll bring this one back here. And we see most of the key parts of the graph at this point. What is the height of the ball the time it's released? That means the time it's released, the time is equal to 0. So we need the y-intercept. So menu, trace graph. We type in 0 and press enter twice. So our graph now is looking like this. Here's our graph. Here's how it looks. And it goes through here at 0, 1.5. That is the answer to A, 1.5 meters. B, find the number of seconds it takes for the ball to reach the ground. Well, that's going to be the x-coordinate here. So let's find that on the graphing calculator now. Menu, analyze graph 0. Click either side of there. And I got, did you get 4.76, 0?
Yeah.
So this is, you want to show a little bit of method here on these ones. So let me do this a little bit better. I'm rushing a bit too much. We want h of 0 is equal to 1.5. On this one, we want h of t is equal to 0, which tells us that t is equal to 4.76. And what's the time in? Seconds. And then C. Find the length of time the ball is higher than 16 meters. This one causes difficulty. So what we need to do for this one is we want to draw a line across here like this and find these 2 points here and here. So this is the line y equals 16 meters. We can do that on the graphing calculator. We press tab and type in 16. And then we can find those 2 points, analyze. We want to find the intersections. Menu, analyze graph, intersection. So we get our 2 values here. This one is at, let me zoom in a little bit here. This one is at 3.94, 16. And this one is at 0.75, 16. So the method that I'm using here is I'm looking for when the function h of t is equal to 16. This gives me t1 is equal to 0.75 and t2 is equal to 3.94. So the time that it's above that is equal to 3.94 minus 0.75, which gives 3.19. All right, we're finished there for today. Let me just point out the homework for today. These IXLs. Sorry, can I just have a bit of quiet for a second? The IXLs are from lesson 1 and 2 are going in Power School on Friday morning for everyone. Power School Friday morning for everyone.